Today we're starting on day 4, which is reasoning and algebra. This whole unit has been talking about inductive and deductive reasoning. And today we're going to focus on deductive. So we're actually going to take a look at what we call some proofs, and we're going to start with algebraic ones. So those are statements that, or an equation that we can solve, but in this case we're actually going to give reasons to why we do each step. So the first 4 properties are actually properties that you did back in Algebra 1. They essentially say as long as you perform the same operations to both sides, that's considered a property of equality. So for example, the addition property of equality says if we start off with an equation, A equals B, then we can add C to both sides and the equation or the statement will still be true. Same thing for subtraction. We can subtract the same thing from both sides, and same thing for multiplication as well. And the only glitch with division is we can divide by the same amount as long as C does not equal 0. Because if it was equal 0, we have a number divided by 0, which is considered undefined. So as I said, all of these properties are back from Algebra 1. They are just reasons why you could do the steps you did in terms of solving an equation. So today we're going to look at a few geometric ones as well, and I want to point out you've got reflexive up here, but you also have reflexive down below. And let me zoom out for just a second so you can see that. So in other words, you've seen reflexive up here and you have reflexive down here. The only difference is reflexive property up here is for equality. Notice all of these are equal signs, and all of the ones down at the bottom are congruent symbols. So the reflexive property essentially says you're looking at your reflection. In other words, you're looking at the exact same thing you started with. So we have A equals A here, or segment AB is congruent to segment AB. Or angle A is congruent to itself, which would be angle A. Next you have the symmetric, and again I want to point out you have symmetric up here and you have symmetric down here. So let's start with the symmetric of equality. It says if A is equal to B, then B is equal to A. So sometimes when we solve an equation, we might have 4 is equal to x plus 1. The symmetric property simply says, you know what, I want that variable on the left side so I can flip it as long as I've kept the same things on each side. So same thing down here. You have AB is congruent to CD, then we have CD is congruent to AB, and again the same thing is true for angles. If A is congruent to B, then B is congruent to A. So all we are doing is flipping what is true on each side of that equation. Okay, moving on to transitive, and again notice you have transitive up here for equality and we have transitive down here for congruence. So transitive, the way I look at this is it's similar to substitution, which we'll talk about in a second, but you have this transition of B sitting in between those two. So it says if A is equal to B and B is equal to C, then eventually we can state A is equal to C. And again, we can go down here and state that same thing. If segment AB is congruent to CD, and CD is congruent to EF, it should make sense that AB is congruent to EF. Same thing for angles. If A is congruent to B, B is congruent to C, then we know that angle A should be congruent to C as well. Last 2 properties, we have substitution. We actually use substitution if you think back in Algebra 1 when you did solving systems by substitution. So for example, if you had y equals x plus 1 and then you had x plus y is equal to 6, we solved this by substitution. We took this piece here and we replaced it, and the reason we're allowed to do that is because x plus 1 is equal to y. So let's go back. If A is equal to B, then B can replace A in any expression. Just like in here, x plus 1 could replace y in any expression. Finally, you have the distributive property. That's when you are handing out a to both of those other terms. So you end up with a times b and a times c. And again, you saw that back in Algebra 1. Let me give you an example. If we had 2 times x plus 1, we multiply 2 times x, and we multiplied 2 times 1. So our goal for the next 2 days is eventually going to be able to prove geometric pieces. But today, as I said, we're going to start off with algebraic. So let's go down and look at that first example. And as I said, this is really back to Algebra 1. You're solving an equation. We are just going to give reasons why we can do the steps that we did. So here's your original equation, and we want to figure out how would you solve it. That's what sometimes I suggest. So if you're going from here to here, one step you might see is you might want to add the 12, and if you notice, that's exactly what they did here, and that shows you what property it is. It is the addition property of equality, and we're going to do a little bit of abbreviation. Let's go to the next one. If we're going from here to here, what did they do? Think back to Algebra 1. They're getting the variables on one side. How did they do that? They subtracted x from both sides. So that is the subtraction property of equality. And then really, hopefully the last step is the easiest one. You're going to divide both sides by 4. And notice again, I said the word for that property. We did division property of equality. So again, this is what you did back in Algebra 1. All we are now doing is justifying why you did what you did. Okay, let's flip to the back side. Number 2, and this one's going to involve a little bit of geometry, but not too heavy. We actually saw this back in Unit 1 if you read through the directions. The nice thing is they've labeled everything, and the only other thing I notice is I've also been given AC, that whole distance is equal to 21. So that first statement, they want to know why are we allowed to state that AB plus BC is equal to that whole length. We mentioned this one, but probably most of you don't remember. It's called the segment addition postulate. The sum of two smaller segments is equal to the larger one. Now we're going to set up an equation. So in place of AB, we've got an algebraic expression. And in place of BC, we also have an algebraic expression. And again, in place of the AC, we have a number 21. The key word was replace. Another word for replace that we saw on the front side is substitution. They helped us out with our next one. They said we want to simplify, and they even went so far to go ahead and put the x. 15 and 4 is 19. So really, when you are simplifying, we are combining like terms. And then finally, to get from here to here, it looks like they subtracted 19. We get 2, and again, notice I said that key word. It was subtraction property of equality. So I would say the first statement is a little bit challenging at this point, and possibly even the second one, but those remaining statements should be, I would say, on the easier side. Let's go look at number 3. And again, before it might say, given the following information, set up an equation and solve, which we're still doing, but again, we're justifying those reasons. So the first thing we have is LM bisects KLN, and in that case, one of our reasons is given. Then they tell us that MLN is equal to the measure of angle KLN. So again, I'm going to mark those angles. That is definition of an angle bisector. And again, if you want to abbreviate, you can just use the angle symbol. Okay, Okay, now we're setting up the equation. So notice again, in place of this, I put 4x. In place of that, I put 2x plus 40. Again, that key word was in place. So again, we did substitution. Now we're back to some Algebra 1 to get from here to here. It looks like they subtracted 2x. So that is subtraction property of equality. And then finally they divided by 2, so that is division property of equality. So again, a little bit of geometry, but again, more heavily focused on the Algebra 1. Both of these statements were more related to the geometry, but from here on down, you're solving an equation. Again, we're just justifying why you did those steps. All right, let's go take a look at example number 4. And I'm going to write it vertically because I think sometimes that helps. So we start off with x is equal to y, and we have y plus 4 equals 3x. And then notice what we did. They have x plus 4 equals to 3x. So we're trying to figure out how did they get from here to here. Well, notice the 3x is still in the same spot. The 4 is still in the same spot. The only difference is we've replaced y with x. Again, the key word is we replaced. So we have x has been substituted for y. So the property we used is substitution, property of equality. Let's look at the last one. Again, I'm going to write it out vertically. We've been given x plus 4 equals 3x. And our next statement is 4 is equal to 2x. Notice the 4 is still there, but what's disappeared? The x has, but it's actually gone from the right side as well. How did we do that? We did the subtraction property. And you know what? That's actually supposed to go down here, and the result is after x is subtracted. So let me go ahead and fix this. Down here is the subtraction property of equality. And up in here should be the word subtracted. Okay, now that you've taken your notes, you're going to get on Canvas. I'm just going to give you 5 quick questions over the properties, and then we're going to focus them tomorrow in class.